So far, we just learned about the encoder, which is a smart reader that understands the input. But now comes the second hero of the transformer world, which is the decoder, the writer, the creator, the one that actually generates sentences, words, and even full, conversation as well. So without the decoder, AI models would understand everything but never know how to reply. So let's now explore the decoder, the creative brain behind models like ChatGPT, translation applications, and the text generators as well. So let's just do a quick recap of what we saw so far, right? So far, what we saw was we saw about the encoder. So the whole idea of the encoder was that we it basically helps you in reading, reads and understand the input. While on the other hand, the decoder whole objective is to write and generate the text, the output. Now think it of like a school exam. You read the question carefully, which is how the encoder works, and you answer or you write the answer in a creative manner, and that's how the decoder works. So both are needed for a complete system. So what is the decoder's role in general, right? So imagine I give you a paragraph in Hindi and ask you to translate it in English. So what you will do? Your whole objective is that first step, right? Step one, you'll first read and understand it. Read and understand the question. Now this is exactly how the encoder works. The second step that you are basically going to do is you'll start writing the English sentence word by word, right? And this is how the decoder works. So decoder job is to generate the output one token at a time and make sure every next word is correct based upon both the input and the previously generated words. So in a non-technical manner, if I have to explain you, now let's say if we write, you know if I ask Ravi is going, sorry, to the, and what next? Now you'll quickly predict market, right? So you know it can be like Ravi is going to the market to buy, and you predict vegetables. Okay, so each if I basically give you that is going to the market in the second iteration, market, okay, to buy, and then I ask you to fill the other one. It's going to be vegetables. So each prediction is basically depending on both the input and the previous word which is already written. And that's exactly how the you know decoder work. And that's exactly what the decoder is supposed to do. So let's look into the fact that how the decoder is basically going to work step by step. So let's basically break down the entire decoder working in simple steps. So the basically the decoder works again in certain steps, and we have now the 7 steps to basically start with. Step one is about working on this input start token. So decoding always start with a special token like or, which is basically the beginning of the sentence. The step two is the embedding and the positional encoding. Just like encoder, the decoder embeds the input token and adds some positional information to it, which is basically the word order, nothing else, right? The step 3 is basically a masked self-attention. Now here is a key difference, right? Uh, because even in encoder we have a self-attention. Here I'm mentioning about the masked self-attention. So the key difference is in encoder each word could attend all other words, right? So for example, the dog chased the cat. The word chased can attend to the word dog as well as the cat. However, in the case of the decoder, at each step, a word can only attend to an earlier word. So, for example, if it was a decoder, the dog chased. The word chased cannot, attend to a future word. It can only attend to the previous word. However, in the case of the encoder, because it had a full sentence, so it can actually attend you know, the future word as well, which is the word after the chased. So this is a a crucial difference between an encoder and decoder. We call this step as a masked self-attention, right? Because we're masking the future words, or you say like the word after you know the word till the point it has come across. Step 4, which is the encoder decoder attention. So after the masked self-attention, the decoder also looks back at the encoder's output. It figures out which parts of the input sentence are important for the current output word. Here, the step 5 is feed forward neural network. Just like an encoder, it passes through a small neural network to define information. Step 6 is generate next word. So finally, the decoder predicts the next word from obviously, which is not next word. I'm actually for the, decoder, it's the next token from the vocabulary it has already created. And then it keeps on repeating, which means it takes the generated words, adds it to the sequence, and repeats the same process until it generates a full sentence or output. So if I basically have to, deep dive to the most important part, which is the masked self-attention, right? Because just like in the case of the encoder, the self-attention is the important part. Here, the masked self-attention is an important part. So let's look into it. So masked self-attention. So masked self-attention, as you mentioned, is very important to understand. In decoding, the model should not cheat by looking at the future words. So very important, should not cheat, right, by looking at the future word. The next thing is it should only see the words generated so far, right? See the words generated so far. So for example, right, if I'm basically writing a story, you don't know the ending in advance. You write step by step, right? So if the output so far is the dog and you are generating the next word, you can only attend to the and dog and not to the future words like ran or away or something like that, right? So spatial masking technique ensures that the model cannot, peek ahead of it. And that's how the entire self-attention is basically, consisting of it, right? Now the other part, of the step was the encoder decoder attention, right? The decoder attention attends to the encoder's final representation. So for example, if I am giving an input text, let's say, you know, Ravi is going to the market, right? The output so far, for example, is, because it's, as I mentioned, it is tokenized, right? So Ravi, let's say VA, right? Now, while generating the VA, right, while generating this, the decoder checks the encoder's memory to realize Ravi and, you know, market is probably the most important word. So it uses the knowledge from the input to generate a better, output. So technically for each, word being generated, the decoder uses attention to connect the correct output, to connect the current output to the input context. So the current output is still now is Ravi VA, and it tries to connect to the input context as well. Now this basically, process helps you with three things. One is, you know, the translations, right? So, you have a matching subject and the object, subject and object correctly. The second one is about the summarization. So, which is like, picking key points. The third is about the dialogue, right? Which is like, giving the local replies in general. Now, we comes across with a final output generation. Once the decoder basically finishes the predicting tokens one by one, the output sequence is complete. For example, in the case of the ChatGPT, right, it basically generates the answer. For any of the translation application, it basically generates the translated text. For the story generator, it basically writes creative paragraph. So, and all of this, happens token by token using the attention and memory. So let's do a final quick recap of our entire, you know, decoder architecture in general, right? So which is like, the summary part. So it's always start with an, input, which is like, the start token and generated token so far. Then it goes to a masked self attention. Now this basically makes sure that it only look at the past and not the future. The third is the encoder decoder, right, attention. Whole idea is to look back at the input in order to understand the context as well, right? Finally, you do pass it through a feed forward neural network, right, to basically refine the representation. And then we have something called as the prediction, which is about, predicting the next word. And you keep on repeating this step until you have attained a full sentence. So the decoder is basically a creative engine of the modern AI that we see. So friends, today we have learned about the second half of the transformer magic, which is the decoder. It's like an artist who listens carefully and then creates beautiful words, ideas, poems, and conversations. In the next video, we'll explore some of the most famous models like GPT, T5, Llama, Mistral, and so many more. Right? And understand how they're basically built using the encoders, decoders, or even both, right? So stay tuned, stay excited, and let's keep learning together. Thank you.